A ladder rests next to a wall of a house, and the wall of the house is assumed to be a smaller friction value than the ground, so we'll ignore it. And our job is to find out what the minimum coefficient of friction where the ladder meets the ground so that the ladder does not slide. So we'll make that our point of rotation right there. And the force coming off of here is going to be known as the force wall. And of course, this is gravity downwards. This one's force normal. And we'll allow a friction force going in this direction here. So let's get some information about the ladder. First of all, the ladder has a value of 210 newtons for its weight. So we'll label it as force gravity equals, and then the length of it, L, is 18 meters. Now, once again, quick reminder about how the forces work on this. We want the force of the wall that's perpendicular, okay, to the ladder. Just think of the ladder as being a lever arm. And our 75 degrees is also here and also over here. So that perpendicular component would require the sine of 75 and also the distance all the way to the point of rotation. And the force of gravity, though, its triangle looks like this. And the 75 degrees is located in here. And this is our perpendicular component that causes rotation about the lever arm. So we have this counterclockwise positive torque here through a distance of 18 meters. And then we have a clockwise torque going this way in a distance of half of that. That would be the 9 meters. And we know the value of this. This is the 210, the weight of the ladder going in this direction. So we will use the second condition of static equilibrium, the sum of all torques equals 0, about this rotation point. So that's going to equal force wall multiplied by the distance of 18, the entire length of the point of rotation, and then times the sine of 75. And again, that's a positive torque because that's counterclockwise. Let's get our negative torque there, 210, which is gravity, multiplied by half the distance of the ladder, 9, because all of the mass looks like it comes from one point, from the center of the ladder. And then we'll add the cosine of 75. And we get force wall has a value of 28.1 newtons. Now, why do we need that? Well, we use the sum of the forces in the x direction next, which is our first condition of static equilibrium. That's going to equal force of friction minus force of wall. Those are our two forces in the x direction, and a ladder, of course, will not move when those are equal to each other. So the force wall also equals the friction force. So force friction then is going to equal 28.1 newtons. So these two will be equal to each other if the sum of those forces equals 0. Well, we know that friction force equals force normal mu, so I'll write that here. I'll say 28.1 is equal to force normal, and the force normal is going to be 210 newtons, the weight of the ladder, since there's no friction about the side of the wall of the house. So that equals 210 times mu. And mu is going to equal 0.13 for this example.